Okay, we're going to finish part 1 of the EOC test review. In the last video, we finished on question number 20. So we're going to go ahead and continue today with 21. We're going to go back over here. And I'm going to, so I can blow it up a little bit while I'm writing it because I know you guys complained that it was too small to see when I was doing it on my iPad. So we'll do it this way. All right, first of all, this is only for number 21. I didn't remember, or I didn't realize as many times as I've gone through this that 20 was on the previous page with number 18. So that just goes with number 21. All right, so define a function. Make this a little bit bigger. It is a relation for which each value from the first set of values pairs with exactly one value from a second set of values. The domain of a function, your x values, which is your input, not input. Your input. Range of a function, y values. Output. They want us to create a table that represents a function. Okay, so I'm going to label it all so that you know what each thing is that's on here. Okay, so we'll have input, x values, output, y, draw a line, another line. My lines aren't half bad on the iPad. All right, and I'm going to put in here -2, -1, 0, 1, 2, and 3. On the bottom, we'll have 0, 1, 2, 3, 4, 5. And I'm just going to separate each value the line. All right, then it says create a set of ordered pairs that represents a function. Well, with the table that we just did here, our x values go with the y values. We already have ordered pairs right there. So there's no need to come up with any more. You can just use the ordered pairs that are in the table that we just made. So we have -2 and 0, -1 and 1, 0 and 2, 1 and 3, 2 and 4, 3 and 5. Okay, now we're going to go over here. And answer number 21 says, consider the table below that represents a function. Which number or numbers below can be placed in the empty cell so that the table continues to represent a function? Select all that apply. So I'm going to go through each number and see if we have them already in the input, because that's what we're looking for. We have an input here. See if the number's already in the input. So 5, we already have 5 right here. 5 won't be your answer. -2, we have -2 right here. Not your answer. -3, we don't have -3 in the input. We have it in the output, which is okay, but we don't have it in the input. So that is a good one. It says select all that apply, so we want to keep going through and making sure. Next one is 8. We do have an 8 there, so that's not going to be an answer. So the only one is -3. Number 22. What does it mean if an ordered pair is not a solution to an inequality? Means it is a false statement. Come on, pen, you were doing so good. Find an ordered pair that is not a solution to this inequality. So I'm just going to start easy and I'm going to do our origin ordered pair, which is 0, 0. I'm going to plug 0 in for X and 0 in for Y and see if it comes out to be a false statement because it says not a solution. So we would have 3 times 0 minus 4 times 0 is greater than 8. 3 times 0 is 0. 4 times 0 is 0. Greater than 8. 0 minus 0 is 0. Is 0 greater than 8? No, it is not. So that is a false statement. That's what they looked for. That's what they were asking for here. So no, 0, 0 is not a solution to this inequality. We'll go to page number 22 now. And it says select the ordered pair that is not a solution to the inequality. So we're just going to go through each of these ordered pairs and plug in the number until we find the one that is not a solution, just like we did on the workspace. Okay. So for here, we're going to take 1 and -3 and plug it in for X and Y. So we have 2 times 1 minus 3 times -9 is greater than or equal to 12. 2 times 1 is 2. Yeah, I did that. I did that math in my head, or I did the math and wrote down the answer instead of just writing down the number. That should be -3 there. Sorry, it happens. So -3 times -3 is +9, greater than or equal to 12. 2 plus 9 is 11, greater than or equal to 12. 11 is not greater than 12, and 11 is not the same thing as 12. So that is not a true statement. It's not a solution. That would be our answer. So we got lucky. Our first try, A was our answer. Okay, number 23. Hopefully this is easier for you guys to see now. It's all trial and error. What does the maximum of a quadratic equation represent? It is greater than or equal to all other values in an equation. The largest value possible. If the x-axis represents time in seconds and the y-axis represents height in feet, what does the maximum represent? Be specific. So we could draw ourselves a quick little graph. It says the x-axis is time, the y-axis is height, and it's talking about a quadratic, so we would have a parabola. And it's asking, what does the maximum represent? So right here, what does that represent? Well, that would represent the maximum height an object will reach and the time it takes to reach that point. Okay, real quick, you guys, I'm just going to check Teams, make sure this is recording. Okay, it is recording and that my mic is on. All right. You'll have no idea how many times I've spent an hour recording a video and then I get to the end and either I didn't share the screen. Wait, let's make sure. Did I share the screen? Yeah, I'm sharing the screen. Okay. Or I didn't share the screen, or I have myself muted, or whatever. And I get all the way through and my work was for nothing. So, number 23, the following graph is a revenue function. It represents the amount of revenue a company generates for each $2 increase in price. The company's max revenue is, so we're going to come over here and we're going to look at our graph. All right, luckily we can fit it on there so that our max is right about here. And if you draw a line over, you can see it's just higher than 1100. Okay, it's not 1,000. 1,000 is where they start the graph and it goes up. 5, it's not 5. When they're talking about $5, they're talking about the price increase down here. So that's not it. What you could say is at $5, they reach their maximum revenue. It's not 20, it's not 1,000. Your answer is D, 1150. It's the only one that's just slightly more than 1100. Number 24, what is slope-intercept form of an equation? Or what is the equation of a line? Y equals mx plus b. How do you graph the equation once it is in slope-intercept form? Use m for slope, b for y-intercept. If you're graphing an inequality with the symbol less than, what does that symbol mean on the graph? And be specific, state two things. It means 1, use a dotted line. Number 2, shade left and or below the line. All right, so here, I'm not going to be able to blow this up too big because I want you to see all the graphs. Actually, yeah, we can do each one individually. This isn't like the tablet at school where it will erase. There we go. They want to know what coordinate plane shows the graph of 3x plus y is greater than 9. So we are going to rearrange this so that we're solving for y. So we're going to move the 3x to the other side. So you get y is greater than 9 minus 3x. And remember, you need to put that in standard form. So it's y is greater than negative 3x plus 9. So now it's in y equals mx plus b form. So we know our y-intercept is 9. And if you look at all of our graphs, they all have y-intercepts of 9. So we're not going to be able to eliminate any graph based off of the y-intercept. So we're going to have to go by slope. Okay, so, sorry, this thing is not wanting to get bigger here. I guess that's big enough. Our slope is negative 3 over 1. So that means we're going to go down 3 over 1. So start at 9, go down 3, 1, 2, 3 over 1. Put a dot there, down 3 over 1. You can clearly see that that is not what they have graphed. So B is not going to be our answer. Take a look at D. Same thing, start at 9, go down 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Again, that's not the line. So D is not going to be our answer. There's another thing that we could do just to make sure that we're right when we're eliminating these. For B, the shading is correct. It would be to the left, so we couldn't eliminate that one. But D, it shades up, so we can eliminate that because we know our sign. Wait a second, the way that I'm saying that is going to be confusing to you guys. Yeah, that's not right. I'm thinking of the, sorry about that. I'm thinking of the question that we just did on the workspace where it said less than. Forget that I just said that. I wish I could rewind and start over, but I can't. So forget I just said that. It's greater than, it's not less than. All right, C, start at 9, go down 3, 1, 2, 3 over 1, 1, 2, 3 over 1. You can see again, that is not the line that they have drawn. You can eliminate C. A is going to be our answer. So start at 9, go down 1, 2, 3, and over 1. 1, 2, 3, and over 1. 1, 2, 3 over 1. That is on the line. So A is our coordinate plane, is the graph of 3x plus y is greater than 9. Number 25, They want us to square root or simplify the square root of 50. The square root of 50 is not a perfect square root, so we're going to need to break that down into prime factors. So the square root of 50, you could start off with any two factors, but I like to have you guys start at 2, just in case you don't know the factors. Starting at 2, if it's an even number, will always work out. So start out with 2. 2 times 25 is 50. 25 is not prime. We can break that down further. So 5 times 5 is 25. Remember, we have 2 5s here. We could take those 5s now and put them out on the outside, just one of them. And then we have a 2 here by itself. So that 2 is going to go back inside a radical. So the square root of 50 is 5 times the square root of 2. Now they want us to write that using fractional exponents. Here I'm just going to write the same thing, 5 times the square root of 2. Using Tybo, we know the square root of 2 has an invisible 2 on the outside and an invisible 1 on the inside. So we'll write our 2. We'll do obit. That's why I don't do videos at night. I'm tired. Out, bottom, in, top. So we're going to take that outside number, put it on the bottom, inside number, put it on the top. So you have 5 times the square root of 2. That's fractional exponents. Okay, this is number 25. So now they want us to select the expression that is not equal to 4 times the square root of 5. So we're going to have to break each of these down. So 2 times the square root of 20. 20 is not a perfect square root, so we're going to break that down into prime factors. We got 2 times 10, then 2 times 5. So now I have a set of 2s. I could take that 2 and put it on the outside with that one. And then put this 5 inside a radical by itself. But we ran out of room. So we're just going to take all of this, we're going to move it over here. It's going to be 2 times 2, and then the square root of 5. We took that and put it up there. 2 times 2 is 4 times the square root of 5. That is equivalent to 4 times the square root of 5. So A is not our answer because they're looking for what is not equal. B, and using Tybo and obit, we know 5, the fractional exponent of 1/2, is the same thing as the square root of 5. Top in, bottom out. You don't even have to put those because they're invisible. And then put your 4 back. So it is 4 times the square root of 5. That is the same as what they have. So B is not our answer. C, we have 9 times the square root of 5 minus 5 times the square root of 5. Because we have the same bases, we can just take our values here and subtract them. So it's really just 9 minus 5 times the square root of 5. And there's no new math or anything. 9 minus 5 still equals 4. And then you got times the square root of 5. And that is equal to what they originally said. So C is not our answer. Our answer is going to be D. And I'm going to show you why. Because 4 to the fractional exponent of 1/2 is the same thing as the square root of 4. You want to finish it, top in, bottom out. Okay, times 5. Well, the square root of 4 is 2. So it becomes just 5 times 2, which is equal to 10. So D is your answer. Number 26, they want us to write out the steps for completing the square to change a quadratic equation from general form to vertex form. I'm going to see, nope, I can't erase that. That doesn't work. Oh, that doesn't work either. Okay, I'm not going to be able to do what I wanted to do. So step number 1, move the number, and when I say the number, I mean the number that's there for the value of C. In this case, it's -10, but we're going to change that in just a second. Move that number to the other side. I don't know why my pen just randomly decides to do this. Clean off my screen. Hold on. Oh, that made it even worse. To the other side of the equal sign. Step 2, is divide your B value by 2. Then square it. Oh my goodness, this is so frustrating. And add it to both sides. Three, change it to vertex form. All right, so I'm actually going to change the problem that they have here, or the quadratic equation that they have here, and I'm going to change it to x squared minus 4x minus 6. Because the other one had fractions and stuff, and I just don't think that you need to have it be that difficult. Okay, so step number 1 says we're going to move the number to the other side. So we're going to take that -6 and we're going to move it to the other side by adding 6 to both sides. So we're going to have x squared minus 4x, and then put a blank here. We're going to add 6 to both sides. So you're going to get equals 6. Now we're going to divide b by 2 and then square it. So -4 divided by 2 is -2. -2 squared is 4. So we're going to put that 4 here. It's a +4. And because we're adding 4 on this side, we need to add 4 over here on this side. Okay, so now we're going to have x squared minus 4x plus 4 equals 10. So since we completed the square, we can factor this, and we can factor it out as x minus 2 squared, because x minus 2 times x minus 2 would be x squared minus 4x plus 4. So we're going to have x minus 2 squared equals 10. To solve for x, you then need to take, anytime you see something that is squared, you need to take the square root of that. So the next step is to take the square root, which would be x minus 2 equals the square root of 10. And we don't need to go all that far. Actually, we could just leave this as that for that specific problem that we're doing. All right, now keep these steps to the side so that you could see them. Like if we were in class and I was doing a split screen so you could see both, you're going to want to do that, because number 26 says the first 3 steps of completing the square to solve the quadratic equation are shown below, and that's exactly the same equation that I just gave you. So we had step number 1 was x squared plus 4x minus equals 6. Then we divided by 2 and squared it to get 4 and added it to both sides. Then we got x plus 2 squared equals 10. Step number 4. If you look at what I gave you, was the square root of x plus 2 squared equals the square root of 2. And yeah, I just realized I accidentally had it as minus 4x on the other one. I meant to have it as plus 4x. Go back here. This should have been plus 4x. So then this would have been x plus 2 squared. There we go. No big deal. Yeah, because the other way wouldn't have given me that middle term. Okay, so for this one, our answer I said square root of 10 and I wrote square root of 2. Our answer here is A. Number 27, we're almost at the end. Number 27, what is a proportion? It is 2 ratios or fractions that are equal. Create your own example and set it up and solve. So a rope's length and weight are in proportion when $20 feet of rope equals 2 pounds, then 40 feet weighs 4 pounds, 200 feet weighs 20 pounds. So Eileen can read 1.5 pages for every page her friend can read. Eileen's mom was very excited and she said to Eileen, so if your friend can read 20 pages, you can read 25 pages in the same period. Is Eileen's mom correct? So if Eileen can read 1.5 pages for every 1 page her friend can read. So she says if her friend can read 20, then how many can Eileen read? So this is where you can do the butterfly. Okay, so you would get 1x, so that's just x, and 20 times 1.5 is 30. So 1x equals 30. 1 can be invisible, x equals 30. So for every 1 page her friend can read, Eileen can read 30. So A, Eileen's mom is correct. No. No, Eileen's mom is incorrect. Well, she is incorrect, but it says Eileen can read 27.5 pages. Same time period her friend reads 20. That's not correct. C, her mom is incorrect. Eileen can read 30 pages in the same time period. That is correct. Or the last one, D, says 40 pages. No, that's also incorrect. So your answer for that one is C. We're on the last few. 28. What does it mean to factor a quadratic? So it means to find what to multiply to get the quadratic. To find the factors. What does it mean to solve a quadratic? Set each factor to 0 and solve. So then they want us to factor and solve x squared minus 3x minus 10. I'm sorry, x squared minus 3x equals 10. We're going to change that to x squared minus 3x minus 10 equals 0. We subtracted 10 from both sides so that we could get our quadratic. To factor it, remember we need to find two numbers that when we take the value of a times c, we get two factors that we multiply them together, we get the value of a times c, but when we add them together, we get the value of b. So we are looking for a times c, a times c. A is an invisible 1, so it's 1 times negative 10. So we're looking for two factors that when we multiply them together, we get negative 10, but when we add them together, we get negative 3. So I automatically think of 5 and 2. To get negative 10, one of them has to be negative. Since this factor is negative, or this value, I should say, is negative, our larger value is going to be negative. So it's going to be negative 5. So our factors are x plus 2 and x minus 5. To solve, set those equal to 0. So we would have x plus 2 equals 0 and x minus 5 equals 0. You can draw your upside down t and solve. So we're going to subtract 2 from both sides on this one. You get x is negative 2. Here we're going to add 5 to both sides. You get x is equal to positive 5. So your solutions are x equals negative 2 and 5. Now they want us to state the larger of the two solutions. So that just means that we are going to factor this, set it equal to 0, find our solutions. So we are going to we need to find two numbers that when we multiply that a times c, we get that value, but when we add them, we get b. So a times c is 90, b is 19. I can look at that and tell you 9 times 10 is 90, and when you add it, it's 19. So we are going to use 9 and 10. Don't let it fool you and you just say, oh, 10 is my bigger number. That's my solution. No. Remember, you're going to put x plus 9 and x plus 10, set them equal to 0 to solve. So we subtract 9, get x is negative 9. Subtract 10, x is negative 10. Now what's our bigger number? Negative 9 is greater than negative 10. So your answer is B, negative 9. It's the larger of the two solutions. Number 29. When do you use the quadratic formula? To find the value of x. Or I should say to find the values, the values of x, the x values. What is the quadratic formula? We all memorized this song, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Told you guys you were going to need that. So hopefully you still remember it. Solve using the quadratic formula. All right, so we need to get this into standard form by subtracting 9 from both sides. When we do that, we get x squared plus 3x minus 9 equals 0. You're going to want to label your values. So our a value is an invisible 1 right here. Our b value is 3. Our c value is negative 9. So we are going to plug those numbers into the quadratic formula and solve. So we have x equals negative b, but instead of b, I'm going to put 3, plus or minus the square root of b squared, but instead of b, I'm going to put 3, minus 4 times the value of a, which is 1, times the value of c, which is negative 9. All over 2 times the value of a, which is 1. We're going to start solving. You're not allowed to use a calculator on this portion of the test. So you need to know these basic multiplications. So you have negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 9 is plus 36 over 2 times 1, which is 2. Simplify that. I'm going to write it down here. You get negative 3 plus or minus the square root. 9 plus 36 is 45 over 2. So your values of x are negative 3 plus the square root of 45 over 2 and negative 3 minus the square root of 45 over 2. 45 is not a prime number, so we need to break that down 40 into prime factors. 45, I can multiply 5 times 9. 5 is prime, 9 is not. 9 is 3 times 3. So if I take those 2 3s out, move them to the outside, I have this 5 here by itself to throw back inside of a radical. You get 3 times the square root of 5. So we then have right here is going to turn into negative 3 plus 3 times the square root of 5 over 2, and negative 3 minus 3 times the square root of 5 over 2. Those are your values, your x values. All right, y'all, we have one more for this packet. And then you guys have a whole other packet. Number 30. What is the axis of symmetry of a quadratic? It is the x value that divides the graph. In parentheses, you can put parabola. Symmetrically. In half. Where is the y-intercept located? It is located where x is equal to 0 And on the y-axis, where the graph crosses it. So it's where our graph crosses the y-axis. What are your x-intercepts? They are the roots, solutions, and zeros. Where is the vertex located? At the minimum or maximum where the parabola crosses its axis of symmetry and where, I should say, for the max, where the parabola stops increasing and starts decreasing. And for the minimum, it is where the parabola stops decreasing and starts increasing. Oh, if we were in class, you would have been yelling, Miss Dowdy, we didn't do number 29. Or did we? Oh, we did. We just didn't come over here and put our answers in. Was this the same? No, it wasn't the same. Oh my gosh, you guys, I'm ready for bed. All right, so this is the same concept as the one that we did for on the workspace. Okay, x squared. I'm going to write it up here somewhere so I have more room. X squared plus 6x, I'm going to say minus 10 equals 0 because we needed to subtract 10 from both sides. When I do that, I now have my values for A, B, and C. A is the invisible 1, B is 6, and C is negative 10. And I can plug that into my quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC over 2A. That other one on the workspace was so much work, I forgot that it wasn't the test question. All right, now we're going to plug in our values. So X equals negative B, which is 6, plus or minus the square root of B squared, which is 6 squared, minus 4 times A times C. Negative 6 plus or minus, oh, and I forgot to put it over 2A. Over 2 times the value of A, which is 1, so just 2. Plus or minus the square root. I don't want that so close together. That looks confusing. X equals negative 6 plus and minus the square root. 6 squared is 36. Negative 4 times 1 is negative 4 times negative 10, and you get 40. So 36 plus 40 over 2. Simplify it some more, you get -6 plus or minus the square root of 76 over 2. Now that -6 can be divided by 2. So far we have -6 divided by 2 is -3. So we're going to have -3 plus or minus the square root of 76. 76 is not a prime number, so we need to break that down. We can start with 2. 2 times 38. 38 is not prime. 2 times 19. We now have all of our prime numbers. So that 2 huh, sorry, I don't see that as one of the answers. We would take that 2 and put it on the outside. Let me just keep finishing what I'm doing, see if it comes together. And the square root of 19. So it would be -3 plus or minus. Oh, okay. I see what I did. Yeah, I should have waited and not divided yet. That's what happens when you jump the gun. So don't divide it yet. That's what I did. So this should still be -6 over 2. Okay. Then we took 76 and we broke it down and we got 2 to the square root of 19. So we now have -6 plus or minus this 2 times the square root of 19 over 2. Now, -6 and 2 can both be divided by 2. So now we get -3 plus or minus. The 2's cancel out the square root of 19. Okay, so see how if you think that you're on the right track and but you don't see your answer that you're going to get, you go back and look at it and try and figure out where you went wrong. That's the best way to learn from your mistakes. So our answer for this one is going to be C. -3 plus or minus the square root of 19. Now we can do number 30. The graph of the function x squared minus x minus 2 is shown below. Which of the following shows the correct key features of the graph? So it's saying, where's our vertex? So it's looking for the vertex, the axis of symmetry, the x-intercepts, and the y-intercepts. So we're going to find those first before we go scrolling back and forth through all of them. Okay, so our axis of symmetry, or I should say our vertex, is right here. They don't have exact numbers, okay? So you could also do the equation that we learned earlier in the packet, which to find the vertex, the x coordinate of the vertex is -b divided by 2a. So b is already negative, it's a -1, so it's going to be a +1 divided by 2. So the x value of our vertex is 1/2. So we can go see if we can eliminate anything, and no, we can't. They all say 1/2. So now let's take that 1/2 and plug it in to our equation for x and solve for y. So y equals 1/2 squared minus 1/2 minus 2. And I just know how much you guys love fractions. 1/2 squared is 1/4 minus 1/2 minus 2. Since you guys hate fractions, if you know your decimals, you can change these into decimals. 1/4 is the same as 25% or 0.25. minus half is 0.50 minus 2. So that's going to be 0.25 minus 0.5. Same signs add and keep. Different signs subtract. So it's 0.25. So you guys hate fractions and I hate decimals. Yeah, I wrote this backwards. See, you guys? I gotta sing my own song. Same signs add and keep. Different signs subtract. So 0.50 minus 0.25. Keep the sign of the larger number. You get negative 0.25. And then negative 0.25 minus 2. So that's 2 minus 0.25. And you'll get, no, now we have same signs. Same signs add and keep. Add and keep the sign. So negative 2.25, which in fractions, because these are all in fractions, is negative 2.25. So our x value is 1/2. Our y value is negative 2.25. See if we can eliminate anything over here yet. 1/2, negative 2.25. Nope, nope, nope. Can't eliminate any of those. Our axis of symmetry is the x value of our vertex, which is 1/2. So this one has x equals 1/2, so that one's correct. This has x equals negative 2.25. That is not correct. That was our y value. Same thing here. X axis of symmetry equals negative 2.25. No. It's the next thing that they look for, the x-intercepts. Well, this x-intercept says negative 1 and 0, and this is 2 and 0. This is negative 1 and 0 and 2 and 0. So there's no point in verifying that because they're both the same. Y-intercept is at negative 2 and 0 or 0 and negative 2. So let's go look. Our y-intercept is at 0 and negative 2. Come on, there we go. So come back over here. And our y-intercept was at 0, negative 2. So D is our answer. All right, guys, great job. Make sure you take pictures of all of your pages of the red writing or whatever color pen you used and upload that to Canvas and get that to me so I can get your second test grade in. All right, see you guys on the next one.